Now we're going to talk about how to graph a sinusoidal function that's in the form y equals a cosine of the quantity b times the quantity x minus d plus c, or the same equation with sine in it, a sine of b times the quantity x minus d plus c. You also may see the c written at the beginning, the number that's added to the function written at the beginning instead of at the end of the equation. Either way, same effect. Now, let's talk briefly from the chart that you filled in about transformations. Hopefully you recall that the y value is affected by the numbers outside the function. So a is the amplitude, causing a vertical stretch in the graph or a vertical shrink. C is the sinusoidal axis. How far up and down does the graph shift? B and D, these two numbers affect the x value. B affects the period, or how wide what is the width of one cycle. D is the phase displacement. How much does the graph shift to the left or the right for its starting point? Also recall that we have 5 key points called the critical points for a sine cycle or a cosine cycle. So here's a sine cycle, here's a cosine cycle, and that when we label the x-axis, the location of those critical points are evenly spaced on the x-axis, dividing the cycle into fourths. Remember, so this is one period for one cycle. So let's graph a few of these and see how we can take the numbers in the equation and draw the graph. So first of all, we have y equals 3 cosine of 2x. 3 is the amplitude. That tells me how far up or down I go from the sinusoidal axis. There is no number added outside the function, so our sinusoidal axis is just still at 0. I'm going to use SA for sinusoidal axis. That takes care of the numbers in the y direction. In the x direction, there's nothing subtracted or added inside the function, so there is no phase displacement. Our starting point, so let me write here that this is our y direction here. This is our x direction. It still starts at x equals 0. But where does it end? What is the period of the graph? Up here, I mentioned that the period is 2 pi divided by b. And you might recall that if we have sine of x, the period is just 2 pi. If we have sine of 2x, multiplying inside the function has the effect of making the period half as wide. The period is only pi. If we were to make this 1/2 x, I put 2 pi, I meant to put 2x in here, sorry, 2x. If this is 1/2 x, this has the effect of making the period twice as wide, and so our period is now 4 pi. Notice that in general we can say that if we take the period and we divide it by the number that's multiplied times our variable in the sine function here, or the cosine function, it gives us the period. So 2 pi divided by 1 is 2 pi. 2 pi divided by 2 gives me pi. 2 pi divided by 1/2 gives me 4 pi. So what we're going to do here is say our period is 2 pi divided by 2, the b value, so the period is equal to pi. So if I go to draw this graph, in the y direction, it has sinusoidal axis at 0. Its high point is at 3, and its low point is at -3 because the amplitude is 3. One cycle completes in pi units. So my key points on my x-axis are going to be dividing that cycle into fourths. So this would be 1/2 of pi, this would be 1/4 of a pi, So 1/4, 2/4, this would be 3/4 pi. Now I'm drawing a cosine cycle, so let's recall that cosine starts high at the highest point, in the middle it's at the lowest point, and then it's back up at the highest point, and in between it's on the sinusoidal axis. So my critical values, my critical points, are going to be at 0, 3, and at pi 3, those are two high points. Excuse me for the voice here. The low point is at pi over 2, -3, and then it's going to be at the sinusoidal axis halfway between. Now when we draw this, it's going to be curved downward from here and here, and then in the middle it's going to curve up. And then when it continues, it's going to start curving back down. So don't make the mistake like some careless students do and make the graph do like this at the end. It never gets higher than 3, so it can't go up like that. Okay, second example here. Now we have a number added outside the function. So this is my sinusoidal axis. This tells me that the entire graph has shifted down 3. So sinusoidal axis is -3. What's the amplitude? How far up and down do I go from -3? Well, the amplitude is always the number that's multiplied times the sine or cosine function. In this case, it would be 1. So these tell me my important values in the y direction. Notice that if I'm starting at -3, the highest I could go would be -2, and the lowest would be -4, because I'm adding and subtracting 1 from -3. The 1/3 x now tells me that my period is going to be 3 times as wide. Instead of being 2 pi, it's going to be 6 pi. So the period is equal to 2 pi divided by 1/3, which is 2 pi times 3, or 6 pi. Once again, no phase displacement, no change in our starting point. It still starts at 0. So starts at x equals 0. So drawing this graph, now I'm going to put the majority of the graph below the x-axis here, majority of my grid, because the highest this graph is going to get is -2. So -1, -2, -3, -4. -3 is my sinusoidal axis. My amplitude is 1, so it's going to go up to -2 and down to -4. On my x-axis, my cycle starts at 0 and ends at 6 pi. Halfway in the middle of my cycle, I'll be at 3 pi. 1/4 of the way through my cycle, I'll be at 1.5 pi. And 3/4 of the way my cycle, I will be at 4.5 pi. This is a sine cycle. A sine cycle starts and ends on the sinusoidal axis, goes down and up like this. So my key points are going to start and end on the sinusoidal axis, and in the middle be on the sinusoidal axis. It's going to go up to its high point 1/4 of the way through the cycle, and down to its low point 3/4 of the way through the cycle. So here is my sine curve. It looks a little ragged right there. There's my sine curve. Now this last example we're going to do is involves all 4 parameters. We have a sinusoidal axis, amplitude, this affects the period, and then our phase displacement. So I like to always start with the numbers outside the function, which would be 3, and then the 1 here, the coefficient of the sine value is 1. So our sinusoidal axis is 3 and the amplitude is 1, which means my high point is going to be at 4 and my low point is going to be at 2. So these are all the characteristics in the y direction that I need to know. The period, now this is interesting. The period is equal to 2 pi divided by this coefficient in here. So 2 pi divided by pi over 6 is the same thing as 2 pi times 6 over pi. Notice what happens here is the pi is eliminated. If we want to get rid of pi on the x-axis, and we often do because when we are using a function as a model, we don't want our x-axis labeled in fractions of pi. We want it labeled in, quote, regular numbers. So if we include pi in this b value, it eliminates the pi from the x-axis, and this is very helpful. The starting point, x plus 2, serves to shift the graph to the left 2. So our starting point is at -2. If our whole cycle takes 12 units to complete and it starts at -2, it's going to end at 10. -2 plus 12 gets me to 10. So in the x direction, these are going to be my important numbers. Now the middle points, there are some middle points I'm going to have to figure out, but I'll do that once I start drawing the graph. So notice all of my important y values are positive values. So I'm going to make the graph, I'm going to go 1, 2, 3, 4. It goes high up to 4. Sinusoidal axis is at 3. And it's going to go down to 2. On the x-axis, I start at -2. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I end at 10. Let's go ahead and find the middle. If this length is 12 from here to here, 12 units, halfway is going to be 6 units. So -2 to plus 6 gives me 4. So there's another key point. Half of 6 is 3 units. So halfway between -2 and 4, I'll be at 1. Halfway between 4 and 10, I'll be at 7. So I've divided my x-axis into 4 equal increments. I'm drawing a sine graph, so it means I start on the sinusoidal axis at -2. I end on the sinusoidal axis at x equals 10, and I'm also in the sinusoidal axis at the middle at x equals 4. At x equals 1, I'll be at the high point, which is -4, and at x equals 7, I'll be at the low point, which is 2. So here is my sine cycle. Now I'm going to give you a problem to try. So if you look at your notes, if you don't have your notes, I will quickly show you that problem. Just a second here. So here's the problem I want you to graph yourself. Right now what I'd like you to do is pause the video, graph this, and then you can check your answer. So I'm assuming you've graphed it now, and I'm going to reveal the answer and talk about it just briefly. Okay, here we have a sinusoidal axis of -2. The number in front of the cosine is 1, so we have an amplitude of 1. So I go up 1 and down 1 from my sinusoidal axis. So there are my 3 key points on the y-axis. 2pi divided by pi over 10 is 20. So my period is 20. I start at a +4, so I'm going to end at 24. 4 plus 20 is 24. Halfway through the cycle would be 10 units, so 4 to 14 would be 10. 4 to 9 would be 5, so that would be a fourth of the way through the cycle. So my key points are going to be when x is 4, when x is 9, when x is 14, when x is 19, and when x is 24. So there is one cosine cycle. I will complete the back side of the notes on a separate video.